Hello class, and welcome to section 11.4c, which is about misleading graphs and statistics. By the end of today's lesson, you'll have a few tools in your belt to figure out when graphs and statistics are misleading. So first, I just want you to take a look at this graph and observe the different, the numbers, the sizes, all of that stuff. And then I want you to go ahead and think for a minute, judging by the size of the players, how many times more points does Messler, so this middle guy, appear to have than Curry? So judging by the size, if you look at the different figures, it looks like Curry is about half of the size. So it appears that Messler is twice as big. But when we actually look at the numbers over here, Messler is probably somewhere around, if you look at the top of his helmet, maybe somewhere around about 290. And Curry is at 230. I think we are all aware that 290 is not twice as big as 230. So then the next question is this graph representative of the player's points? The answer to this is no. It isn't true that Messler has twice as many points as Curry. So that would be no. The ratios or the size of the graph doesn't match the data. So people are able to make graphs so that the data being representative is accurate. So the numbers work out here. This is 290 and this is 230, but the visual part of it doesn't match the numbers. So we can say that by looking at it, it gives us different information than if we actually pause and read the graph. So now I want you to look and I want you to decide which graph is more misleading, graph A or graph B, and then explain your answer. In this case, graph B is more misleading, once again, because of the size. So they give you the same information. The bars are very accurate as to the different pieces of information, but the size of the soccer ball makes it seem like we could fit at least 3 of these smaller ones inside of the bigger one, and that is not the case. The data is not 3 times as big in the first one compared to the second one. So you want to be really careful when you are looking at graphs that you're looking at the scale that they're using, at the size of the pictures that they're using, because it is really possible for people to create graphs that make it seem like one thing is happening when the data is actually telling you something different. So now we're looking at 2 different graphs. The first question is, since the graphs show the same data, so 4, 4, 5, 6, and 8, again, 4, 4, 5, 6, and 8, why do they look different? The reason they look different is that we have a different scale on the y-axis. So we are counting by different values. In the graph on the left, we're counting up by 4s. In the graph on the right, we're counting up by 2s. So it's giving you the same information, but just in a different way. So the second question then becomes, which graph makes it appear that the prices have a bigger increase? The answer for this would be graph B. It looks like the numbers are higher. They look bigger because the scale is different. Now looking at these 2 graphs, graph A and graph B, which graph suggests that the business is extremely profitable? Make sure you're explaining your answer here. So graph A makes it look more profitable because they're counting by smaller numbers. So it makes it look like the graph or that their profits are going up higher even when both graphs actually show the same data. So you want to make sure you're always paying attention to the scales, the labels that graphs are using, so that you aren't misinterpreting the information that they are trying to portray to you. Last thing we're going to look at is some misleading statistics. This kind of ties back into when we were talking about appropriate measures for central tendency. So we're looking at this list for the various roller coaster heights in a particular park, and the park says that the average height of its roller coaster is 170 feet. And then it asks us, why is this misleading? So we look at 170 feet, and you notice that 1, 2, 3, 4 of those roller coasters are below that, and just one is above. So this is misleading because there's an outlier. And as we learned earlier, outliers really affect the average. So this is misleading because there is an outlier, and then you want to make sure you say what the outlier does. So the outlier brings the average up too high. So it makes it go up higher than it should be. It pulls all of the data upwards towards it, even when that's not an accurate reflection of where most of the roller coaster heights are at. So now you're looking at a menu, and this restaurant claims that the average menu price is $3.50. Why is this misleading? Once again, there's an outlier in the coffee, and in this case, it's bringing the average lower than it should be. So again, you always want to make sure that you are looking at statistics and graphs with a little bit of a skeptical eye, trying to figure out what the group or person using these statistics are trying to tell you, making sure that they're using good scales on their graph, making sure they're not trying to include an outlier to make the data get skewed. And we always want to make sure that we're looking at statistics with just a little bit of skepticism and making sure that they're accurately reflecting what the data actually says. If you have questions about this or anything else from the lesson, please let me know and feel free to reach out.